The next topic, very important topic, transformer. So this is very important topic from your 4th lesson, 12th standard physics, detailed question answer. Transformer. What is mean by transformer? Transformer is a stationary device used to transfer electrical power from one circuit to another without changing its frequency. So please note it down children. Transformer is a stationary device used to transform electrical power from one circuit to another without changing its frequency. Then the applied alternating voltage is either increased or decreased with corresponding decreases or increasing of current in the circuit. If the transformer converts, and this point is very important, please listen carefully. If the transformer converts an alternating current with low voltage into an alternating current with high voltage. Once again repeat, if the transformer converts an alternating current with low voltage into an alternating current with high voltage, it is called step-up transformer. So there are two kinds of transformer. One is the step-up transformer, another one is step-down transformer. So what is the important condition for the step-up transformer? Voltage is increases, current is decreases. So alternating current with low voltage into an alternating current with high voltage is called step-up transformer. On the contrary, if the transformer converts alternating current with high voltage into an alternating current with low voltage, then it is called step-down transformer. So once again repeat, if the transformer converts alternating current with high voltage into an alternating current with low voltage, then it is called step-down transformer. Then next point, construction and working transformer. Construction and working of transformer. The principle of transformer is mutual induction. Please note it down children. The principle of transformer is the mutual induction between two coils. That is, when an electric current passing through a coil changes with time, an EMF induced in the neighboring coil. So whenever the magnetic flux changes, the induced EMF is increases. That means electric current passing through the coil is changes, means the magnetic field also changes. And EMF is induced in the neighboring coil. So this is the mutual induction concept. So construction is, in the simple construction of transformers, there are two coils of the high mutual inductance wound over the same transformer core. In the simple construction of transformers, there are two coils of high mutual inductance wound over, this is the two coil wound over the same transformer core. The core is generally laminated and is made up of good magnetic material like silicon steel. Please note it down. This magnetic material like silicon steel. This is the primary coil. This is secondary coil. NP is the number of turns in the primary coil. NS is represent number of turns in the secondary coil. Then IP is represent the current passing through the primary coil. IS is represent current passing through the secondary coil. VP it is represent primary voltage. VS is represent the secondary voltage. The next, the coil are electrically insulated but magnetically linked via transformer core. So laminated, the coil should be laminated, that means insulated. Because of that time only we reduced the eddy current. The coil across which alternating voltage is applied is called primary coil. And the coil from which output power is drawn out is called secondary coil. So, coil across with the alternating voltage is applied is called primary coil B, and the coil from which output power is drawn out is called secondary coil S. The assembled core and coils are kept in a container which is filled with the suitable medium for better insulation and cooling purpose. The assembled core and the coils are kept in a container which is filled with the suitable medium for better insulation and cooling purpose. The next important thing is working of transformer. If the primary coil is connected to a source of alternating voltage, so this primary coil is connected to the source of alternating voltage, and alternating magnetic flux is set up in the laminated core. If there is no magnetic flux leakage, then whole of magnetic flux linked with the primary coil is also linked with the secondary coil. This means that rate at which the magnetic flux changes through each turn is same for both primary and secondary coil. As a result of flux changes, so what happens when the flux changes in the coil means automatically EMF is induced in the both primary and secondary coil. The EMF induced in the primary coil or back EMF epsilon P is given by. So according to the Faraday's law concept, whenever the magnetic flux changes, the induced EMF produced in the coil. So the voltage in the primary coil, that means epsilon P is equal to minus NP into d phi B divided by dt. The next step is, but the voltage applied Vp across the primary is equal to the back EMF, then Vp is equal to minus Np into d phi B dt. The frequency of alternating magnetic flux in the core is same as the frequency of the applied voltage. So please note it down. Frequency of alternating magnetic flux in the core is same as the frequency of the applied voltage. Therefore, induced EMF in secondary will also have same frequency as that of applied voltage. The EMF induced in the secondary coil epsilon S is given by epsilon S is equal to minus Ns into d phi B divided by dt, where Np and Ns are the number of turns in the primary and the secondary coil respectively. If the secondary circuit is open, then epsilon S is equal to Vs. So where Vs is the voltage across secondary coil. So Vs is equal to minus Ns into d phi B divided by dt. So from equation 4.24 and 4.25, Vs divided by Vp is equal to Ns divided by Np. So dividing these two equations, d phi B divided by dt, d phi B divided by dt cancel to each other. So remaining term is Ns divided by Np is equal to K. This constant K is known as voltage transformation ratio. Voltage transformation ratio for an ideal transformer. This is very important formula for your 2-mark question as well as the objective type question. Please note it down. Input power Vp Ip is equal to output power Vs Is, where Ip and Is are the current in the primary and the secondary coil respectively. Therefore, Vs divided by Vp is equal to Ns divided by Np is equal to Ip divided by Is. This is very important formula. Please note it down for your 2-mark problem as well as the objective type problem question. Vs divided by Vp is equal to Ns divided by Np is equal to Ip divided by Is. Then equation 4.27, the last equation here, this equation is written in terms of amplitude of corresponding quantities. Amplitude of corresponding quantities. Vs divided by Vp is equal to Ns divided by Np is equal to Ip divided by Is is equal to K. So this 2 point is very important for the step up and the step down transformer. If Ns is greater than Np, that means the number of turns in the secondary coil is greater than the number of turns in the primary coil. So this voltage ratio, transformer ratio, K is greater than 1. Then Vs is greater than Vp. That means voltage in the secondary coil is greater than the voltage in the primary coil. And current in the secondary coil is less than the current in the primary coil. This case of step-up transformer in which voltage is increased and the corresponding current is decreases. So, step-up transformer, what is the condition of step-up transformer? Voltage is increased and the corresponding current is decreased. So, this is the condition for the step-up transformer. Then, second condition is, if number of turns in the secondary coil is less than number of turns in the primary coil, transformer ratio is less than 1, K is less than 1, then the voltage in the secondary coil less than the voltage in the primary coil, and the current in the secondary coil is greater than the current in the primary coil. This is step down transformer where voltage is decreased and the current is increased. These 2 points is very important point for your 2 mark as well as the objective type question. The next important 2 mark question is efficiency of transformer. What is meant by efficiency of transformer? Efficiency is represent eta. The symbol is called as a eta. Eta of a transformer is defined as the ratio of the useful output power to the input power. Ratio of the useful output power to the input power. So, eta is equal to output power divided by input power into 100%. So, transformer are highly efficient device having their efficiency in the range of 96 to 99%. Various energy losses in transformers will not allow them to be 100% efficiency. So, please note it down. This is very important topic, efficiency of transformer to a objective type question and as well as the 2 mark question topic. The next one is very important topic in 3 mark topic, energy losses in a transformer. Energy losses in the transformer. Transformers do not have any moving, so that its efficiency is much higher than that of rotating machines like generator and motors. But there are many factors which lead to energy loss in a transformer. So, first loss is core loss or iron loss. What is meant by core loss or iron loss? This loss takes place in the transformer core. Hysteresis loss and eddy current loss are known as core loss or iron loss. Hysteresis loss means magnetized and demagnetized of the material is mentioned the hysteresis losses. Eddy current losses means the material, whenever the magnetic flux changes in the primary and the secondary coil, which produce the eddy current. So, part of the energy should be losses in the eddy current pattern. So, eddy current losses, hysteresis losses is the are known as core loss or iron loss. When transformer core is magnetized and the demagnetized represently by the alternating voltage applied across primary coil, hysteresis takes place due to which some energy is lost in the form of heat. Hysteresis loss is minimized by using steel. Please note it down. This is very important point. Hysteresis loss is minimized by using steel of high silicon content in making transformer core. Alternating magnetic flux in the core induced eddy current in it. So, therefore, there is energy loss due to the flow of eddy current called eddy current losses, which is minimized by, please note it down, eddy current loss which is minimized by using very thin lamination of transformer core. The next, copper loss. Copper loss, transformer winding have electrical resistance. Transformer winding have electrical resistance. When an electric current flows through them, some amount of energy is dissipated due to Joule heating. This energy loss is called copper loss. Copper loss means electric current flows through them. Some amount of energy is dissipated due to Joule heating. This energy loss is called copper loss, which is minimized by, please note it down, which is minimized by using wire of larger diameter. Then the losses is flux leakage. Flux leakage happens when the magnetic lines of primary coil are not completely linked with the secondary coil. So, flux leakage happens when the magnetic lines of primary coil are not completely linked with the secondary coil. Energy loss due to this flux leakage is minimized by, note it down children, very important point. Energy loss due to this flux leakage is minimized by winding coils one over the other. Winding coils one over the another. So these are all the important points of the energy losses in a transformer. Then the next topic is advantages of AC in long distance power transmission. Advantages of AC in long distance power transmission. So the electric power is produced in the larger scale at electric power station. That means Neyveli electric power station considers a Neyveli with the help of the AC generator. These power stations are classified based on the type of fuel used as thermal, hydroelectric and nuclear power stations. There are two power stations. One is the hydroelectric and nuclear power station. Most of these stations are located at remote places. Hence, the electric power generated is transmitted over long distance through transmission lines to reach town or cities where it is actually consumed. This process is called power transmission. But there is a difficulty during power transmission. A sizable fraction of electric power is lost due to the Joule heating. That means I square R. In the transmission line which are 100 of kilometers long. This power loss can be tackled either by reducing current I or by reducing resistance R of the transmission lines. The resistance R can be reduced with thick wire of copper or aluminum, but this increases the cost of protection of transmission lines and other related expenses. So this way of reducing power loss is not economically valuable. The next step for the long power transmission is we can use the step up and step down transformer. Economically, it is very easy to transfer the electrical power from the power station to the city substation. Since the power produced is alternating in nature, there is a way out. The most important property of alternating voltage that it can be stepped up and stepped down by using transformers could be exploited in reducing current and thereby reducing power losses to a greater extent. At the transmitting point, the voltage is increased and the corresponding current is decreased by using step up transformer. Then it is transmitted through the transmission lines. This reduces the current at high voltage reaches the destination without any appreciable loss. At the receiving point, the voltage is decreases and the current is increased to the appropriate values by using step down transformer. This is a step up transformer. This is a step down transformer. Number of turns in the primary coil is decreases, number of turns in the secondary coil is increases, then number of turns in the primary coil increases, then number of turns in the secondary coil decreases. So this is the turns ratio. This turns setup is represent the step up transformer. This kinds of turns is represent the step down transformer. So when the power is entered to this step up transformer, the voltage is increases, current is decreases. In the second step down transformer process is voltage is decreases, current is increases. So at the receiving point, the voltage is decreases and the current is increases to appropriate values by using step down transformer, and then it is given to consumers. The power transmission is done efficiently and economically. Power transmission is done efficiently and economically. So this is a very, very important topic for your 3-mark question. Thank you very much, children.